Thank you very much. I'm pleased to meet you all. It's my first time in Sweden, and it's the first time in a hacking conference where IKEA is a sponsor. So that's, Swedish things. So today I'm going to talk about AWS, Amazon Web Cloud Services, and how we're going to attack and what kind of attack vectors in both the exploitation and the post-exploitation process. Then I'm going to show some demos. Hopefully they work. So that's me. That's how I look like in my traditional dress. It's called Rutra. It's really nice and stylish. Some racist people call it a table cover. Idiots, right? So I've done some talks and trainings all around the world, in Europe, in Asia, in the Middle East, of course. My focus currently is on API security in the cloud. Basically, the reason I chose this profession is working on cloud security allows me as an individual in Kuwait to actually reach out to the entire world instead of being constrained to the local, regular enterprise environment in Kuwait. And Kuwait is really small, so why should I constrain myself in that small geographic area when there are 7 billion people in the world who need, to be secured? So that's why I chose cloud security as my current profession, of course. So that's my personal reason for it. That's my GitHub and my Twitter, if you are interested. So where is Kuwait? Kuwait is, of course, in the Middle East. Can anybody find Kuwait? Yep, that small one, that's Kuwait. And you see that it's in red. Can anyone guess why? That's why Kuwait currently holds the official highest record for temperature. 52 is actually in the shade. Yeah, and out in the sun, it once reached, arguably around 60 Celsius degrees. So that's why, I came to Sweden to just, have a change of the temperature. Currently in Kuwait, in September, it starts to cool down. So now it's about 46 Celsius degrees. In American, that's 3 barbecues, or I think 120 Fahrenheit, right? So, yeah, it's really hot in Kuwait. Kuwait is also known, other than heat, Kuwait is known for the Kuwait Towers, which was actually designed by a Swedish architect, so thank you very much. Kuwait is also known for its really good food, and if you look at me, you can tell, right? So if you visit Kuwait, don't do it in the summer. That's number one. Visit the Kuwait Towers, and by the way, the pointy end is actually very sharp. Don't ask how I know. And do, take your time to actually see, taste all the food in Kuwait. When people come to Kuwait from the neighboring countries, they actually go on a diet before they come to Kuwait. So, before I start my talk, I would like to actually start with the references, because I stood on the shoulders of giants. Those are the main references I used for my talk. I don't like to mention the references in the end when I am rushing for time. So I actually would like to start with the references. These are 2 really good books that you might want to take a picture of if you're interested in cloud security, secure DevOps, and that whole profession. So, why would I attack AWS? Because AWS is the king of the cloud. Currently, it has the lion's share of public cloud services. They are well documented and widespread. When I say well documented, I mean that it's all written, but they change the documentation so much, you actually need to have someone who only specializes in all the API documentation changes, and there are people who actually do that because there are lots of services in Amazon. In AWS, you have the basic services from S3, the file cloud storage, all the way to ground satellite stations. So Amazon AWS provides really big, let's say, assortment of services. So that's, for example, what I'm talking about, AWS ground station. I don't know who uses that. While security inside AWS itself is actually excellent, market awareness of security, in other words, the customers and how they can use AWS securely, is actually lacking. So let's talk about how AWS changes the security, let's say, model for you. In a better way, many attacks don't work inside the cloud. For example, you don't have to care about ARB spoofing inside Amazon. You don't have to care about destruction of your old hard disks, for example. The data center security, now you don't have to care about that anymore. Worse is that your model, some, let's say, parts of your traditional model don't work as well. So, for example, IP reputation is less effective because attackers can just attack you from inside Amazon. So, the same applies to country blocks because Amazon has lots of regions over the world. So, a country block is actually less effective. So, you need to actually upgrade your security model. The security model of Amazon is called a shared responsibility model, which means that the responsibility is split between you and Amazon. Some things you have to handle. Amazon will not help you in that. And some things Amazon will carry on for you. So for example, Amazon takes care of the hardware, the storage, electricity, physical security, and all of that. And you have to care for your own applications, your own servers. There are some managed services inside Amazon like S3 and RDS. Amazon will handle that for you, the backups, for example. You take care of your customer data, you take care of your credentials and all of that. So if I want to attack a customer inside Amazon, now note that I'm not talking about attacking Amazon AWS itself, attacking customers inside the Amazon cloud. So if I want to attack, these are the most popular attacked services in Amazon: S3, the distributed file storage inside Amazon; EC2, which are the virtual cloud servers inside Amazon; RDS, the managed database. Amazon manages the DB for you, including all the updates and backups, so you only connect to the database and send your data. And Lambda, which is the offering of Amazon for their function as a service feature, which means that you only upload your code, your function, and Amazon runs the environment to execute that function for you. So you don't have to care about updating the OS, for example. Now, attacks against these, let's say, services usually are being done for data theft, mining cryptocurrencies on your expense. So someone could, for example, attack your Amazon account, and then they take your keys, and then they run cryptocurrency miners, and you're going to pay for all that processing, and they'll gain the mining operation on your bill. And of course, ransomware, but that can be made less effective because Amazon allows easy backup and restore inside the cloud. Now let's talk more about EC2. EC2 is Amazon's fancy name for virtual VBS servers. So basically, you choose your size for your own VBS. You can choose the type, is it Windows or Linux? And then you can just log into it using SSH, and then you can just manage it just like any other VBS. Of course, you have no say in which hardware runs on your EC2, and you don't have any info about the neighbors inside Amazon that are running next to you on the actual hardware host. You're responsible for the OS and the updates and the host security inside. So in this image, do you see the mouse cursor? Yeah. So that's your instance. It's inside Amazon, and you connect to it through the internet using your SSH key. And then you manage this server just like any other server that you have. So in reality, it's nothing special. You can just attack it the usual way you attack any other server. An exploit against any running service, web applications, for example, OS command injection, local file includes, and of most importance for us is SSRF, server-side request forgery. SSRF is a vulnerability in which you ask the trusted server to access internal services on your behalf. So for example, you'll ask the server, connect to this private IP for me, and then the server will connect and then give you back the result. So the reason SSRF is special in the cloud is because Amazon and also Google and I think even Azure, they have this special feature called instance metadata, an internal metadata service that runs inside every virtual server in the cloud. This metadata URL is usually this IP, and you can call, this is only internal to the instance itself. So only the instance from inside its own OS can call this URL. And of course, if you call this URL using an SSRF vulnerability, where you're outside and you ask this vulnerable instance to talk to this URL and then give you the result, you're reading it from inside the instance. This internal metadata service can expose interesting stuff like credentials, other interesting details about the metadata, the server itself, which we're going to see next. Also, if you want to attack EC2 instances, you can attack what they call the user data startup script. When you create a virtual server in Amazon, you can specify a script that runs every time the server boots up. For example, it could be a configuration for updating, for example, your source code from your GitHub repository, updating packages. So usually it contains some sensitive data like passwords. Amazon also, if you see this image, you can attach to the server an EBS, which is Elastic Block Storage. What it means is that it's just like a regular small flash memory virtual disk that you can attach to the cloud. If you can detach that and then access it, you can find interesting data. For example, if you are running Active Directory inside Amazon Cloud, you can maybe copy this NTDS file, which contains all the hashes. So these are the main types of attacks that are special to AWS instances. Now, SSRF, usually, in the old web vulnerability days, it actually lived in the doghouse. Nobody cared about SSRF. It was always low priority, won't fix, or even totally ignored. So people always cared about RCE, SQL injection, cross-site scripting. Nobody cared much about SSRF because they thought it was, it didn't have that powerful demo ability where you can easily demonstrate how dangerous it can be. Now, Amazon came and saved SSRF. SSRF in the world of cloud became king. In the cloud, SSRF vulnerabilities can result in full infrastructure takeover. So we're not talking about takeover of the server or the database itself. We're talking about full takeover of the entire AWS account of that customer. For example, as we said, we can use SSRF to contact the local metadata service running inside this AWS instance. For example, you can ask for the security credentials that are running with the server. So for example, I did this from inside one of my instances. I called the internal metadata service, asked it for the credentials of the current server, and then it gave me an access key and a secret, which are the username and password for the Amazon API. Using this, I can just plug it inside Amazon's API, and I can make requests that will allow me to get access to whatever resource this instance has. I'm going to show a demo for that very soon. So I'm going to show a project made by Rhino Security Lab. It's called Cloud Goat project. It's an intentionally vulnerable application. Now they have version 2, but I'm going to display version 1. We're going to use SSRF to actually try to get more interesting stuff from inside the metadata. So I'm going to show it actually in a demo now. So that's the page. If you see, the design is really nice. It's actually responsive. You don't see it? Come on. Jonas, would you mind kindly help with this? Do you see the slides now? No, nothing shows. So I'm going to plug this one out and plug it back again. See if it works. OK, now let's see if this, OK. So as I said, it looks nice, and the design is responsive. So now this is a simple URL fetcher application. Don't laugh. That's my design skills. So what this application does is that I give it a password, and then I give it a URL. It will go and fetch that URL for me. OK? So I'm going to, where is the password for this one? That's the password. Don't want you getting my keys, right? So I'm going to, for example, connect to google.com. Now it will call google.com, not from my own IP, but from inside Amazon. So as far as Google is concerned, it's being contacted from inside Amazon. So that's really nice. So far, it's really basic. People use SSRF vulnerabilities for things like accessing internal IPs and all of that. So as we're going to see, it fetches a URL for you. When I did this screenshot, it was actually falafel day. So the Google dork, showed all of these this falafel sandwich. So that was nice. Yeah, now I'm hungry. Good thing lunch is coming next, right? So basically, we now understand what SSRF does. Can we try protocols that are not HTTP protocols? So instead of calling pages, maybe I can call an FTP protocol. Maybe I can call other services running other protocols instead of HTTP. So we can try the file protocol. Let's see the demo. Okay, you can't see the demo again. I don't know why this happens. Okay, so let's go back again. Let's try which file do you want? Of course, everyone's favorite, right? So now we can call the file protocol. So it's not just HTTP protocols. You can call basically whatever, depending, of course, on the library being used in the backend. So that's nice. Now we have access to much more than just HTTP. You can read the local configuration file. We can read source code. We can read all of that. So what else we can do? Back again, sorry. Why don't we try something else? Why don't you try the proc file system? Anybody knows what the proc file system is? I don't see many hands being up. Okay, good. So the proc file system is a special file system, a virtual file system inside Linux, which allows you to have access to certain properties of each process and certain properties of the current process. And it is attached like a regular file inside Linux, so you can access it using /proc and then the process ID, for example, 5 or 10, and then some info inside it. So some interesting info inside the proc file system for each process could be the starting command line options, environmental variables, memory mappings, ARB cache table, mounted devices, and even the executable itself. So if you have, for example, an application that's actually a Python script, you can use the proc file system to read its own source code, for example. So let's see an example here. I could call /proc and then /self, which means the current process. So I don't even have to guess my process ID. So I can just use /proc /self, and then I can use command line to see the command line that was starting this current process. This is interesting because people could start processes like this, right? Application, and then using the flags for this name and password. So this would, for example, show up for me using /proc. Can also use /proc, the virtual proc file system, to read the ARB cache table inside the server. So this is interesting because now I can see other IP addresses and other MAC addresses inside the current network. I can see what kind of devices they run. I can see more targets for further exploitation in the local network. So this is actually a sample that I ran on my instance. So it's really nice to have these. If you think about SSRF in ways beyond just HTTP protocol, you can see really interesting stuff. And of course, we can just call the AWS metadata service like this. It's a URL, returns for you directories. So I'm going to show right now. So I'm going to say, so I need to copy that again. Okay, so now let's see the metadata service, HTTP. Good thing I already have it here. So I'm going to show how it starts. Then step by step, we're going to read up the metadata service. So retrieve the contents. These are the metadata service directories. With a bit of trial and error and reading the documentation, you can see which methods are actually interesting for you. Copy the password again. Okay, so now metadata. Let's go back and then say metadata. Supply the password again. Okay. Metadata. I did? Yeah. Wow. Oh, now I didn't put the password. Okay, so now we have it. Lots of interesting stuff. Now, Amazon's identity and management service is called IAM, so that's where we're going to check next. Of course, I'm cheating because I know beforehand, but eventually you want to try and see everything inside here because these are some really interesting, juicy information. Then IAM, then the password again. This is getting really annoying, right? At least it works. By the way, if you want to hire me for my web design services, I don't recommend that. So, security credentials. Now we are getting more interesting stuff. Credentials, copy the password again. Okay. So now EC2 S3 read, that's the role name. That's the role I gave to this server to run. So obviously, it can, for example, access S3 buckets using read-only privileges only. So now I could use this, and then also layer the password again. And it would show for me the credentials, actually the access key and the secret access key. So I can take these and then just plug them inside my own, inside the Amazon AWS API, and then you'll have access to this role. Whatever permissions that role has, you will have also, so you can call any API that you want. So let's go again back to the slides. We've seen how we can call the metadata service, really simple. As we said, the credentials. So what can I do with this? If you want to know how dangerous this can be, you can just ask the Capital One Bank, which I think a few months ago, they were compromised using what is thought to be an SSRF vulnerability inside an instance running a WAF, and that's really ironic. So what the attacker did, it was a she, by the way, she actually used this SSRF vulnerability, and then she got the Amazon access keys from inside the instance metadata service, and then used that, she plugged it in the Amazon API, and then used that to call and read the S3 buckets of Capital One Bank, including, I think, millions of customer data and all of that. So this results in a really big, let's say, breach for SSRF. So if you want to try something like this, of course, if you're authorized, you can use this tool that I made. You know how the need is the mother of invention? So I was doing consultation with my clients in the cloud, and then I realized there are some steps that I needed to automate and I needed to make easier. So I made this tool. What it does is, it's a post-exploitation attack. So it assumes that you already have gotten your keys, for example, through the SSRF vulnerability. And then you can just use this tool to launch some attacks against the AWS environment. For example, you can dump the credentials saved inside this Amazon account. Amazon provides for you a credential store, like a vault. It's called AWS Secrets Manager and AWS Parameter Store. Inside this, you can, for example, add your encryption keys, database password, and all of that. And of course, there's an API for it, so you can just query it and then have access to the secrets themselves if you have permission, if your key has permission for that. You can remotely control EC2 instances. The only way to control an EC2 instance is to use the SSH key that was set up in the initialization process of this server. If you don't have this SSH key, then you can't log into that EC2 server. There is a way, of course, from inside Amazon's API. It's called System Manager that can allow you to have root or administrator access shell on that server without having access to the SSH key. So I made the tool Barq to actually utilize that. Now, Barq means lightning in Arabic, by the way. So you can see from the logo. You can get Metasploit Meterpreter reverse shell on the EC2 instance coming from inside Amazon. So the connection is going to be from inside Amazon services. So it's going to be really more difficult for traditional defense mechanisms to actually detect that. And of course, dump EC2 instance metadata, do some attacks against Lambda functions. We're going to see. When I created Barq, I actually wanted to try out the AWS API features. So I made a training mode inside it. So if you want to use it, you don't have to actually mess up a running production environment. You can just use the training mode, which will create for you some services, temporary roles and servers, and then you can attack them. And once you're done with the training mode, it will clean up after itself, and it will actually try to utilize all the free features from inside Amazon. So it will try to use the size of EC2 instances that is actually inside the free tier of Amazon, so we want to get billed for it. This is an example of how you can, how the training mode works. It asks you, do you want to create a Linux or Windows instance? What kind of payloads do you want to utilize? For example, Metasploit. And then you can have here your own listening server that listens to the Metasploit reverse shell. So we are using the Metasploit reverse shell here. And then you hope to get a reverse shell coming back to you. So we're going to see that in a demo very soon now, and I hope it all works. I'm not going to do the same dance here. Okay, so also it can dump credentials inside AWS. It can give you more information about your attack surface, well, how many servers, how many functions are there, how many security groups. And now I'm going to show a demo. Next, of course, for this tool is to create more Lambda function attacks, make it modular, add some persistence and backdooring features. So now I'm going to do the demo, and I hope everything works fine. So, okay, ASCII logo, you know, hackers love that. So I'm going, you don't say anything. You know, just tell me beforehand, guys, okay? So I don't get embarrassed like this all the time. Now it shows up, right? And as I told you, ASCII logo. You want to see it again? Okay. Nice. Thank you very much. I love this crowd. So where was I? I'm going to copy my credentials. So I'm going to say set profile. Give it the credentials. It will ask for passwords and it will not show them because it's a demo mode. So and now it will ask what is your preferred region. I'll use the default one because it has the largest set of supported API features. Help. Let's see what we can do. Let's try the training mode. Help again. Start. Okay. So it will now create the temporary environment for you. It will say, do you want to create a Linux or Windows environment? Let's say Linux. It will now choose a certain type of Amazon image for the server. Now it will take a few minutes to create it, hopefully much sooner, so we have to wait for it. Meanwhile, I have a server that's waiting for the connection, so hopefully it will work. Now, if you noticed, if you want to use this feature inside Barq, you need to have this permission inside your Amazon API role. So Amazon EC2 role for SSM, which allows the SSM service, the system manager service, to run commands inside your EC2 servers. So that's the main role that you actually need for this feature to work inside. So okay, now we have created it. The instance is created. What kind of attack do we want? Let's see metasploit. What IB do you want to use? I'm going to choose this IB. Now I'm going to. Okay, so what port? That's the port. It will say what kind of shell do you want. Now it will give you the command that you can just copy paste inside your listening server just to make it easier to prepare the listening environment. So now it will launch the listener for us. Then it will try to create a payload. It expects that Kali, that Metasploit is installed on your own system. So this is a Kali Linux server, so it has the ability to do that because Metasploit is already installed. Now it's sending Meterpreter Python-based payload. That's the command it's sending to the instance. Now we will see if we got, okay, so now we have got a session. See that? Now I get to do the same dance, right? Sessions, and then one. And now I have the session, sysinfo. So now this is the Amazon server connecting back to me. If I get, for example, a shell, now I have a shell inside Amazon. So inside the Amazon EC2 server, even though I don't have access to the SSH key. So that's one way you can do post-exploitation attacks inside the server. Once you're done, the training mode will understand that you have returned, and now it will say, okay, now I'm terminating the instance, cleaning up, deleting the role, and everything. And then after that, it will tell you that you are now done, and that's it is finished. So let's wait for the training mode to be complete. Now, okay, so now it is done with the training mode. Everything is cleaned up. I don't hear any clapping, so that's really. Thank you very much. So If I want to use this tool in production, I can just use the attack surface function. This one will go through your entire Amazon in all of the regions available and try to find any server that's running inside this region, because Amazon uses lots of regions in the United States, in Europe, in Asia, in South America, for example. Now recently in the Middle East as well, in Bahrain. So it will go through all the regions, try to find all the servers and the Lambda functions running inside the region, try to give you all your options for any activity, any post-exploitation attack that you want. So for example, here we can see we have some Lambda functions. It also displays the environmental variables for them because they could contain passwords and secrets, API keys, for example. So let's go up, up, up. That's an instance that was stopped. We have Lambda functions. You can see their environmental variables, for example, Twitter API keys. So the environmental variables for Lambda functions could contain some sensitive information. Let's go back up again. These are our instances, for example. They're public IP. So it gives you, let's say, a whole view of your own environment. Let's see some EC2 attacks. We can list all the images that we have. Now let's run some attacks. You can choose against all instances or just one. So I'm going to say just one. And then I'm going to have to paste or just use temp completion for my instance. So now it will say, what do you want to do? Download the metadata for me, for example. This one is really simple. It will go and send this Python command, which will actually display all of the metadata service from inside this EC2 instance. You can also do a reverse shell. So now we can see we also, again, have the access to the access key and the secret access key, and then you can use this one inside, for example, for more attacks. So that's basically it. Now we can go back to the slides. OK, next for me, I'm going to describe the Lambda function. In EC2 servers, you're responsible for running the server, and nobody likes that because we don't like to update OS, we don't like to update the environment, we don't like to update all the Windows updates if you're running Windows servers. So Amazon allows you to just put your code files, Python, Java, for example, and then Amazon will create the environment that runs for you. They call it serverless, of course. There is a really small server that lives for less than a second to execute your function and then go back again. So no server operations needed for serverless. The vulnerabilities against serverless functions are the regular application vulnerabilities like OS and RCE. There's a special type of vulnerability that affects serverless functions. We call it serverless event injection attacks. The way serverless functions work is that they don't accept input from users directly. They accept input coming from events, which are events triggered from inside Amazon itself. So I'm going to show an example of what an event could be. For example, suppose I have a serverless function that does virus scanning. So I listen on an S3 bucket, and if anyone uploads any file, I will try to scan this file for viruses on malware, okay? So the way this service would be written is that it would listen for an event from S3 bucket. And anytime someone uploads a file on the bucket, Amazon itself will trigger the event for my Lambda function, telling my Lambda function and a file was uploaded in S3. So who's actually invoking my serverless function? It's Amazon itself using the event. So this is not the regular model in regular applications where I know for sure the flow of functions and how each function calls the other. That's why in these gaps in the assumption of how the functions could be called, we can have these type of attacks inside Lambda functions. Inside Lambda functions, because you don't have a server that you can manage anymore, some regular attacks don't work as well. So for example, if you upload a file, if you have a file upload vulnerability, it would not work inside Lambda. Why? Because the file system inside Lambda is mounted as read-only, except for temp, and because the instance itself is short-lived. It is started by Amazon for a few milliseconds to return the code, and then it will be destroyed. So whatever file you uploaded will be gone in a few milliseconds. The same applies to any reverse shell that you have. It's not going to be persistent. There is no metadata service inside Lambda, unfortunately, for attackers. Of course, no local files are usually sensitive inside Lambda. So how can I attack Lambda functions? I can try to dump the environmental variables inside Lambda to gain access keys. So Lambda's access key and secrets are stored inside its own environmental variable instead of the metadata service like in EC2 instances. I can use Lambda to actually, for example, backdoor it. I can download the source code, study it, see if it's anything, let's say, sensitive inside, and then I can even upload my own source code to the Lambda function. I can just backdoor it, add whatever line that, for example, sends the credentials to my server, and then I can upload that and backdoor the function. So these are the sorts of events that could come to Lambda functions: API gateway calls, S3 files, database events, for example. Remember the example I told about the Lambda function for file scanning? Suppose that it does this. It calls OS system in Python, and then it takes the bucket that it received, and then it, for example, copies it to another file system or another bucket for the virus scanning. So, of course, what we have here is a regular OS command injection attack. So I'm going to show a demo now. It's called OWASP Down Vulnerable Serverless Application. It's a project contributed to OWASP by a company called Partigo Labs. I'm going to show, because I already installed it. Basically, it's a web shop for games. You can just buy any game that you want. And if you buy the game, if you go through the process of buying it, I'm not going to show that. You're going to receive a message from the application itself telling you that we have processed your order. And then you can just download your receipt from here, okay? Of course, I made this a long time ago, so the link has expired. I can do it again, but I think we're running out of time. However, let's check what kind of link that we have here. It's a bucket inside Amazon that uploads my receipt to a certain directory. So what it does is that this application takes my order and then creates a receipt on a bucket and then allows me to upload my receipt. So what if I try to, of course, this is a process if you want to test yourself. I'm going to upload the slides. You can just try it yourself like this. So if I access this file directly, it's actually downloadable. And now I can audit the permissions on that S3 bucket. This one, for example, allows anyone to upload, allows any AWS account to upload. So for example, I can just copy this command. I'm going to create a file, an empty file. OK, so echo. OK, now let's see if we are connected to my AWS account. OK, so now I'm just going to copy this command. What it does is that it will upload this file to this bucket. Now it says it uploaded the file. So I'm going to access this file. What was the file name? So now I can access the file. It is public because I was able to. The first vulnerability in this application is that it has an S3 bucket that allows anyone to upload to it. So now we know that this, if you check the source code of this application, you'll see that one of the functions actually handles uploads from inside S3. So if you check the code here, it says bucket. Do you see the mouse cursor? You don't see the mouse cursor? OK. So let's do it the old way, OK? Like this. Now you can see the cursor, right? OK, so it listens for events from an S3 bucket, and then it will try to take the file name itself, the key, which where the key inside S3 means the file name. It will do some operations on it. It expects the file to have an underscore, and it expects the file to end in .row extension. So then it will take this file, the file name, and then it will do echo date, and then it will echo for me the actual file name. So what it says is that it will send out to the output of the system that this file name was downloaded in that time. Of course, if you check this, this is a regular command injection attack, but the file name is being taken from inside S3. So someone could say, you know what? It's OK. It's an event coming from inside Amazon. So what could go wrong, right? The thing is, S3 can accept any type of name, so any type of file name. Even if it contains commands inside the file name, it will be acceptable. Of course, I will try an attack now. I set up my listening environment using Negrok. What I'm going to do is that I'm going to run this command. So what this command does is that I'm going to upload an empty file to my bucket, and then I'm going to, inside the file name, I'm going to give it a command, curl, to post the result of the whoami command to which address? To my listening address. I set a Negrok listener, and then I'm going to put .row in the end so that the function triggers, and then I'm going to upload this file. If this happens, and I go back to this command here, it will take the file name, right? Which is whatever, and then semicolon, curl, and then it will run the curl command and send whatever is the result here. So now I have my Negrok listener waiting, and then I'm going to open the Negrok web interface, waiting for requests. Now I'm going to copy the command. I already have it prepared. Now let's try to do it again. It says uploaded. Let's see. OK, so now we have something in Negrok. We have a request. If you see the post data, it's what? It's the username of the function. Only one clapped. Thank you very much. Unbelievable. So let's try something else. Let's try, for example, this command. See if we can get something else going on. Let's try a command that requires multi-lines, OK? That's why we put it actually inside the post request for curl. So we have a request now. Uname, that's the command, the results, and then the listing directory. So what really happened here is that the attack came not from outside, but actually from inside Amazon's own infrastructure. So it was an event sent by Amazon. That's what we call event injection. We injected our attack inside the event that would be sent from Amazon to the Lambda function listening for us. And then we utilize the vulnerability inside Lambda itself, the code, to actually run our own command. So that's basically how it works. Thank you very much. Thank you very much. Now, why don't we try something that's more useful for us as attackers? Let's try the command called env, which prints the environmental variables, right? Now let's see if we have. OK, so these are the environmental variables. You can see the tokens and the keys. Where is the key? Secret. OK, so that's the AWS secret key. So that's the same as the metadata attack in the EC2 servers. Inside Lambda, it's in the environmental variable. If you want to try this tool, after you're done, make sure you delete the bucket and then you delete the stack from inside CloudFormation feature inside Amazon, so that you don't leave your environment vulnerable for long. So as we said, the environmental variables contain all the interesting stuff. You can use Lambda function as a sort of an automated backdoor. So you can create a Lambda function that listens, for example, for any addition, any user being added to this account. And then if they get added, you steal their code, their access key and access token, and then you send it outside. Or, for example, listen for any new instance that gets created. So Lambda can also be used as a backdoor mechanism where you're listening for an interesting event that happened in the victim AWS account, and then you act upon it. Now let's talk about the permissions servers inside Amazon, the IAM, identity and access management service inside Amazon Access, right? I think so. So this manages for you the users, the roles, the groups, the API access keys, permissions, and trust relationships. So we're going to see how that works, especially of course, we've seen the API access keys. We've talked about this one a lot. Let's talk more about trust relationships. A trust relationship inside Amazon allows you to give temporary access for other entities to your own role. For example, suppose I have an instance, an EC2 instance, and I want it to be able to upload files to my S3 bucket. So I create a role called upload files to S3, and then I attach this role to this instance. Now this instance, when it runs, it can use this role's permission to upload files to my S3 bucket, because this allows me to actually create an environment where I don't have to use hard-coded keys, because Amazon will store these keys for me inside the instance metadata. Now, when you attach this role to this EC2 instance, you're creating a trust relationship. You're saying that this instance, the EC2 instance, can assume this role and gain temporary credentials for it to use it to call the AWS S3 APIs to upload files to it. So this feature, the trust relationship features, is through an API called STS assume role. Of course, it has lots of interesting, let's say, use cases. It can allow you to actually use it across accounts. So suppose I have an Amazon account for my environment, and someone else's account can call this function if I allow them to. An example, if I have an environment that is for production, an environment for developers, and they want developers to temporarily be able to, for example, deploy functions or deploy resources on the production environment. So I can use this STS assume role policy document. This is an example, okay? Suppose we have a dev account with this ID, and then we have a production account with this ID, okay? And then we have an administrator role on the production account. So this is the Amazon resource name for the role of administrator under the account of all fours for the production account. I want to allow my developers in the dev account to temporarily be able to use this role to, for example, deploy servers. So I will say allow which principal, this principal, the account all tools for the dev account. Now it means that any user on that dev account can use this call to temporarily get credentials for the administrator role on the other production account and then deploy servers. And then once we're done, the temporary credentials will be gone. So if I was an attacker, I could do the following. I could add my own Amazon attacker ID, and then add it to the list of whoever is allowed to call this role. So now I will be able to use the Amazon's IAM update assume role policy to attach and backdoor the role itself here. So this is really interesting, because that's not one of the things administrators or defenders inside Amazon really look for. They tend to look for the traditional stuff, but this is AWS specific stuff, so you should always add these roles and their policy documents to your integrity checks to check if someone has played with it and added their own account ID. So that's one way of how you can backdoor an AWS account. And I've seen it happen with administrators being fired without having the access removed for them, so they do this quick backdoor stuff to be able to hurt the organization that fired them. One of the best AWS attack tools to actually do this exploitation and post-exploitation attacks is called Paco. It's made by Rhino Security Labs. It can do some of the attacks we discussed, for example, backdoor assume role to add your own, for example, account ID to the assume role policy. It can also create a model called Lambda backdoor new users. What this model does is that it will create a Lambda function. Anytime a user gets added to this account, it will backdoor that user, create an access key and secret key, and then steal that to a server outside for you. So it's currently the most feature-complete open-source AWS attack tool in the market. Before I finish, these are the resources again. If you are more interested in AWS than we started with, maybe now we want to take a picture of these really cool books. And if you're done, then I'm also done. So thank you very much for your attention. Any questions? I'll be happy to answer. Thank you very much.
Thank you, Mohammed. These are all very nice just features, right?
Thank you.
No. What do you think is the biggest misunderstanding when people start talking about security in AWS?
They don't read Amazon's documentation. They think it's just another server in the cloud. It is, but you have lots of documentation and features inside Amazon that integrate with these servers and databases inside Amazon. So if you don't really follow up and understand the environment you're running on, you're bound to have problems.
All right, but it's like a pet peeve, like even the people that have read the manual always misunderstand this part. Is something like that?
Yeah, you can say.
Yeah?
Yeah.
All right, do you have questions from the audience as well? We have 10 minutes before. There's one question there in Mac. Do you have a mic runner that can get there?
Where?
Is there a mic runner on this side? Oh. I think we need 4 mic runners in here. It's so big.
Thank you for a great talk. So do you have any quick comments how to find and mitigate these vulnerabilities?
First of all, where are you? I don't see you.
Over here.
Where? OK. Yeah. So the question again, please.
Do you have any quick comments on how to mitigate these vulnerabilities? I mean, you said there were features in the Amazon cloud, but do you have any great way to find these real quick?
OK. So if you notice, everything we discussed so far resulted one way or another of one of 2 things. Either you have an application vulnerabilities in your own servers and your own application that resulted in exposure of your own Amazon API keys, right? And then the second half of the vulnerability was that those keys usually had much more privileges than they needed, right? So if you really give good attention to your application security, plus understand really how Amazon's permission system works, you can really reduce and sometimes even prevent any post-exploitation attacks from being meaningful on your own Amazon environment. And that's easier said than done because Amazon has, I think, almost 6,000 permission types. Half of them don't allow customization, so it has to be star, like everything. So there is still lots of things to do in terms of security and permissions, even from Amazon's side. So it's a really difficult problem to actually tackle. I'm not going to say it's easy. I'm not going to say just do that. No, it's actually a really difficult problem. I hope that answered you. Thank you.
Right, the question over here.
I am curious as to what is Amazon's take on this set of issues, because they usually say that they take security seriously. Are you aware of that?
Yeah, you know, when someone says they take security seriously, we don't tend to believe that. But the thing is, I don't blame Amazon. It's a really huge infrastructure, and it's really difficult to make changes with infrastructure as it is running. I mean, it's a live infrastructure, millions of customers. They just can't change everything on a whim. So it's really difficult even on their part. And I'm sure they are more interested in securing their own environment. I'll give you an example. Remember the instance metadata we talked about? Remember how easy it was to call it? You just give the SSRF vulnerability the URL to call. Google Cloud, for example, in comparison, requests a special header to be sent. So you can't really add a header when you use an SSRF vulnerability. So it kind of defeats the instance metadata exposure inside Google Cloud because they request an internal header to be set with the request. So, of course, you can still attack it in Google Cloud if you have an open proxy, for example. But it greatly limits the exposure of the instance metadata inside Google Cloud. And I really think Amazon is supposed to put something like this, such that you need to add something extra, not just the URL itself, to attack the instance metadata. So, yes, there's still lots more to be done, even on Amazon's side.
Yeah, it's hard to tighten up security once it's deployed, right?
Yeah.
Microphone coming.
So how often do you end up walking into something where people have had training on this and they still are absolutely freaking clueless?
Really all the time.
Okay.
It's complex. See, when I told you that Amazon has 6,000 permissions and half of them don't require customization, they can only be like a wildcard. It's not an easy problem to solve. But if you know your infrastructure well, if you know your environment well, You can make it really secure. I've seen some organizations do something else different entirely, such that the users don't have accounts on the production environment at all. So they only, let's say, authenticate from another account. So this kind of, segregates the duties and makes the problem a bit more difficult for the attacker to actually reach out everything inside it.
More questions?
Any
All right,
question?
No?
Is
In
it
that case, thank you, Mohammed.
Thank you.
Thank you very much.
Thank you for your attention.